It's my pleasure to introduce today's speaker, Richard Wessels. Richard has a background in geosciences with a focus on earth materials. And as my colleague, he plays a key role in supporting researchers with access to the imaging facilities in the Excite network as access manager. Richard is also involved as a data scientist in the EPOS multi-scale laboratories. This puts him in a unique position in the interface between Excite and EPOS and facilitated development of the practical solutions for fair data publication. Actually, the topics of today and last week's webinar by Peter Mone. So today, Richard will introduce the Excite fair data publication workflow and show how researchers can take practical steps towards publishing imaging data sets in an open and fair way. So Richard, take it away.
Excellent. Thank you, Selene. I'll try and take over the screen here. Let's see. Is that working? Excellent. Great. Okay, so yeah, thanks again for the introduction. My name is Richard Wessels, and as Selene already mentioned, I wear many different hats. One of them, and where most people know me by probably in this community, is from being the access coordinator of the transnational access that we offer under Excite. But I'm also heavily involved in the data aspect of Excite and of the work that we do. And that's where my talk today will be about. So I'm going to present to you a practical guide on publishing your data in a as fair as possible manner. I obviously don't take all the credits for this myself, because we have been working on this guide with a large group of people from the Excite network. So Peter Mone, Geertje de Maat, Ralf Dieselin, and Milad Nadelou. And as Selene already mentioned, we also work together with European and other international initiatives on setting up this data publication workflow. One of them I would like to mention, my colleague Ronald Pijnenburg, who's also here at Utrecht University and who's involved in EPOS. Another player here is StraboSpot, and it's a tool that I will also introduce to you today, where Basil Tikoff is one of the main drivers from Wisconsin University. So today's presentation, I'll have split it into two parts. So one is more the sort of the theory, which is a short section, and then I go into the actual publication workflow. So let's take one slide step back when we talk about fair data. I'm guessing here most of you by now know what fair data is, especially if you've been to Peter Mone's presentation last week as well. But for those who don't know it, FAIR is an acronym. It stands for Findable, Accessible, Interoperable, and Reusable, where the findable concerns that people must be able to find your data before they can actually do something with it. Accessibility basically reflects that if someone has found your data set, then they must be able to obtain it. So your data set must be stored in a location where it can be accessed from, where it can be downloaded, and where it can actually be stored for a significant amount of time so that it stays there persistently. The I is for interoperable, and that means that your data is actually can be combined with other data sets. So say that you have published tabular data, that is published in a certain way in which you can integrate it with other tabular data. That is very simply put what interoperability is. And the last bit is reusability, because it's nice if people can find it, download it, and combine it, but people must also be allowed to actually do that. And that's what reusability is. So that's very much focused on licensing your data in a way that others can actually work with it. Now, fair data is it's not a binary scale. It's not you're either fair or you're not fair. Fair data is more like a gradual scale. And with this workflow that we'll present today we're trying to advance the fairness of your data. So trying to take small steps to make your data better findable, more easily accessible, more interoperable, and better reusable. Or as Peter Mone likes to mention this, fair is a mindset and not a checkbox. So our perspective on data sharing, so where does Excite sit? So as you see here, we are mainly involved in creating data that comes out of our analytical facilities. So we have a wide number of them, as Selene already mentioned. So we produce research data, and subsequently we want that data to be reusable and to be used by others. So we publish it through trusted data repositories that are then linked to international data catalogs such as EPOS, where you can go to actually specifically look for this data. As we will mention EPOS a couple of times, I thought it's good to introduce it for those that do not know what this is. So EPOS is actually a European project. It's what is called an infrastructure project, which consists of 28 member states that contribute to it. And the goal of EPOS is to essentially make all earth science data findable and accessible and downloadable from a single portal. So the idea is that we try to link up with data repositories that provide their data into EPOS, providing a single place where you can go to download the data. Now, because the whole European landscape is quite broad, EPOS is basically broken down into 10 thematic communities, which are shown here. One of those communities is what is called the multi-scale laboratories, and that's actually where all the equipment of Excite also falls under. So basically, Excite is it's not a part of EPOS, but we utilize the same instrumentation that goes into this multi-scale laboratories domain. That's a little bit about that. Now, why would you actually want to publish your data? I've listed here a couple of items on that. First of all, because sharing is caring. So publishing your data openly actually increases the impact and the transparency of your research. If you do that in as fair as possible manner, it improves the data availability, findability, and the visibility of your data. But it also has to do with the trustworthiness of your data. Because when you find data from others, if that's properly described, properly organized, it builds more confidence in that the data is actually good and that the data can actually, or is actually worth reusing. And the whole FAIR process is also geared towards that. One of the other things is that nowadays datasets directly can get cited. So you can actually build a citation on datasets as well. In principle, it should improve the reproducibility of research. So if others can find your data, sift through that and figure out exactly what it is that you did, then that means that it's more easily to reproduce your research, which is actually one of the key pillars of scientific research in general. And one last bit, that's our stick. That's a compliance aspect, and that's that it's more and more required by funders to actually publish your data in a fair manner. For those who have done transnational access on the TNA, that's the same. So in both Excite 1 and the current Excite 2 project, we ask from our users that they deposit their data within 2 years following the acquisition as per our data policy. So anyone who has done transnational access with us, they have actually signed off on this, saying that they will publish their data within 2 years after acquisition. So in principle, this is useful for everyone in Excite. Right, that's the background of this. Now let's actually go into the data publication workflow itself. So what we have been doing for the past year with the group that I showed on slide 1, we've been working on this sort of workflow, this process of publishing your data, what is needed at which point, and trying to put that into a document that we've now actually made available on the website. So as you would go to this link or just follow the Excite network, you can go to the Access Fair Data Publication Guidelines. And there's a number of documents that help you in making your data fair. So a lot of the aspects that I will present in like the next 20 minutes or so, they're actually featured in this practice training material. So you can find that, or you can read that back at your own leisure by going through this page and going through the documentation there. So what we have done now, we've basically broken down this process into a number of discrete steps. So you first start off with collecting your data, selecting a repository, creating your data set, assigning metadata, licensing, and then in the end, you publish it and you can actually, or you or others can discover the published data. So I'll just go through these different steps and highlight some of the things to keep in mind and some of the interesting aspects that come with it. So first up, when you are actually collecting your data, as I already said, so in Excite, by doing access under Excite, you actually you commit yourself to publishing your data. So when you are collecting it, that's the thing that you should keep in mind, that this data has to be published. So you can already start thinking about how to organize it, how to structure it in a way that it's in the end more easily to publish and to put out there. So one of the main things obviously there is the actual structure of your data to keep that logically and then consistently throughout your data set. The metadata that will eventually be published with your data set, but most of that is already acquired during the experiment itself. So during the experiment, it's important to keep track of the configuration that your instrument was in, like what detectors were on there, what was turned on or off, acquisition parameters, acceleration voltage, those kind of things. Sample specs, what kind of samples did you put in? How were they prepared? What were the dimensions? Those kind of things. And which humans are involved. Because the roles of people involved in the experiments, they're also important because you can indicate them in your data publication. So everyone gets the right credit that they deserve. In the last couple of years, there's been quite an explosion of electronic lab notebooks that are available to help you with that. So my advice would always be to, when possible, actually use one. That said, I have myself a very little experience with electronic notebooks, but I know from colleagues that it's actually a very helpful thing to use. So if you have access to it, I would suggest to look into that and to try and use that as much as you can. The second step, so you've actually now obtained your data, you have conducted your experiments, you are now at the point where you want to publish it. Then the first step that you then have to do is actually select a appropriate data repository. There are some general criteria to keep in mind when you try to select one. They're listed here in order of priority. So the best thing that you can do is to find a disciplinary repository. So that means a data repository that's actually geared to or specifically made for the type of data that you produce. That's the best. If you can find one of those are where you want to go. Another step is that sometimes you can use an institutional repository. They're often geared towards specific larger domains, you could say. I'll come back to those in a bit. Another option is that you use what we call catch-all repositories. So they're not thematic, they're not geared towards a certain type of research, but they are out there, they're available, and they're also good places to actually store data. So Nodo is probably the most known from that aspect. If you want to find a repository, there's actually a couple of websites, a couple of tools out there that you can use. One is fairsharing.org. They provide an overview of repositories that you can look into. Another is Read3Data. They actually have quite a neat way of browsing it. You have this wheel where you can click on and then dive deeper into specific domains, and then you end up with a list of repositories that fit with that. And now, having said that, unfortunately, in the realm that we're mostly in, which is sort of earth and environmentary science and then microscopy-related research, there's no real dedicated repository for that. So sort of this first option, that is just not available to us. So we have to actually find other repositories that are useful. Now, one way of looking at that is to take this from the perspective of the findability of your data. So once you deposit your data in a repository, the data is harvested through, say, Google. So it can be found through search engines, but it can also be harvested through these data catalogs, such as EPOS. So ideally, you want to deposit your data in a data catalog that's not only searched or harvested or categorized by search engines, but is actually also linked to these larger ecosystems or data catalogs where all this data is being combined. Now, one of the or a list of repositories that are actually linked to, say, this EPOS realm are shown here. So using any of these repositories is actually a good idea because putting your data there ensures that the data will subsequently end up in this EPOS ecosystem, so in those large data catalogs where you can then search for specific data. When it comes to Excite, there's one additional thing that I would like to mention, and that's specifically for Excite TNA users, so both of Excite 1 and of Excite 2. We offer actually the data repository that we have here at Utrecht University to publish your data. So you can contact us, you can publish your Excite-related data free of charge through our system. On the Excite website, there's a specific document detailing you who to contact, which steps to take, and how to get there. As you can see, it's only 2 pages, so it's fairly straightforward. But also there, if anything is unclear, feel free to contact me directly and we can help you through that. So that's specifically for Yoda, and we've already helped actually quite a few researchers in that way. So yeah, please don't hesitate to contact us for that. If you've selected your repository, be that Yoda, be that Zenodo, be that anything else, very good before you proceed is actually checking their FAQ or contacting their repository manager to find out things about file format regulations, sizes of data sets that you can download, any templates for, say, README files that they have, instructions for the metadata that you need to provide, and obviously if there are any like financial costs related to publishing your data there. Like I mentioned with Yoda, it's free of charge if you've been an Excite user, but actually a lot of repositories, they ask some fee to deposit your data there. Okay, so that's great. So you've now actually selected your repository of choice. Then is basically start to create your data set. And some things to keep in mind there. For your data to be fair, the formats that your data sets have, they should be open. It means they should not be limited to certain vendor software or to certain applications. So one of the things is that, for instance, tabular data, many people use Excel to create it, but actually when you publish it, it's better to do that in a CSV format because that's actually an open format. There's a couple of other examples listed here, TIFF or PNG for images. JSON is a very common format for metadata. But the same with documentation, right? You may actually start making that in Word or something. But when you publish it, it's better to do that in something like a text file or an MD file. The same goes for naming. So when you give names to your files, actually, make sure that they are descriptive. So not just something like random or data or new, but actually give it a name that is descriptive, so that when someone sees it, they can already directly interpret or get an idea of what this will contain. So sample types, configuration settings, you name it. You can already include that in the naming. When you are structuring your data set as a whole, it's important to keep a structure that's clean and simple. On the right-hand side is an overview of how you can structure a data set. There's many different ways, and that's obviously dependent on the type of data that you've actually acquired. So this will be different for any new data acquisition, basically. So it will slightly differ. But still you can generically use this format here when you want to organize it. So you can start with adding README files with information about metadata. You can split your data set in raw and processed, organize it per sample or per analytical type, anything as long as it's structured, consistent and understandable for someone who is looking into your data. A brief intermezzo here, specifically for people that are dealing with two-dimensional data. Because for that, there's a sort of additional part of this workflow that we would like people to use. And one of the things here that we are trying to help with is the actual referencing of 2D imagery data on top of each other. So say you have a thin section there, you've obtained smaller imagery data from a certain locality, you've extracted a TM foil or other, or you've done laser ablation on top of it. All of that you want to be able to reference with respect to your initial sample, so that it's so that people can understand where the data was obtained. Now, to do that, we've actually in Excite been looking at some of the open source correlative microscopy tools that are out there. And one of the conclusions was that one of the tools that is most promising for now is what is called Strabo Micro. And that's actually an initiative from the United States, which is open and openly available to everyone. And there's a very collaborative bunch of people behind it that are really engaged in improving it and making it better. So what this does and what it allows you to do is to correlate, nest and reference 2D data on top of each other. This is a very simple example of that, where you have a large thin section with a mineral map positioned on top of it, and it's referenced, so you know that the mineral here corresponds to whatever is sitting behind it. So this can actually help you in organize your data sets. And while you are doing that, so while you're using that to organize your data, you're actually using and applying metadata that was created with Excite and with EPOS. So for instance, you can select the instrumentation from the Excite network that you used, and we've already added the necessary metadata behind that. So in this case specifically, this is a scanning electron microscope, so we've already added the detectors and what kind of settings that they have in there. So you can just select with which instrument the data was obtained, and then that directly fills in the needed metadata there. So it helps you also later on in structuring your metadata in your data set. If you've then done that, actually one of the outcomes is a specific file that we ask you to then include in your data publication. A few examples are shown here. And the reason that we ask you to do that is that what we eventually are aiming to do is at the site of EPOS actually create a viewer that allows you then to view and browse through those data sets using images as the basis. So this is essentially our goal there. So please, anyone, if you are actually interested in utilizing Starble Micro to reference to the imagery data, contact me. I can give you some guidance on actually how to do that and some specific things to keep in mind. There's too much there to actually go into all the detail, but yeah, just make sure to contact me, and then I'll help you with organizing your data there. Let's continue with the general flow of publishing your data. So now that you've structured your data set, you actually need to assign metadata, and that basically means that you have to create a README file that describes all the elements in your data publication. So this will contain information about the licenses, context, which is very important. So why was the data obtained? What was the purpose of the experiment or the idea behind your research? The type of samples that were used, the data types that are in there, any acquisition specifics, and an overview of the folder and file structure. So there are templates of README files that you can download at the resource shown here. You can also always, if you find a data set that has a README file where you think like, that's actually a nice one, you can just copy that and use that as a template. There's no problem there. When you describe your data set, it's actually important to use keywords to describe your data. So these are actually terms that specify what your data is about. With the help of EPOS, in collaboration with them, we've created a tool, which is a keyword selector that you can actually use to select community approved keywords. So an example is shown here, where you can select different terms that are actually, that have a definition behind it, and that the community agreed on, that those are terms that are useful and that people can use. Because what we're trying to make sure here is that when someone says granodiorite, that everyone understands what that is. So for that, it's important that we all use the same terms and the same keywords. Let's see, the last bit is on licensing. Licensing is actually a more important aspect than a lot of people realize. What you generally have, if you just look at copyright licensing, is that you have two options. Either you have something called all rights reserved, which means that no one can do anything with it unless you give explicit permission to that person to do so. And the other option is no rights reserved, meaning that it's completely open and anyone can do anything with it, whatever they like. Very often you want to have some kind of in-between option where you can tell people that they can do certain things, but not all things. And that's actually where Creative Commons licenses come in. So they create a kind of some rights reserved option for granting others permission to use your data. Now in Excite, what we've done is we've created what is essentially a flowchart for you to follow to end up with a license of choice. There's not per se a better or worse license. It's just that every license has specific characteristics and specifically states what others can do with that. So you can just follow this workflow, and then by answering the questions that are asked here, you will end up with an idea of what kind of license is available to you. You can also go to the Creative Commons website, where all of that is explained in even more detail. In principle, going through this very briefly, is that licenses go from very restrictive to more open, and that means that people just have more, they can do more things with your data. So very restrictive would be that someone can use it, but they're not allowed to alter it, to transform it, to even build upon your work. So that has some usability, but not much. It even goes towards the fully open license, so where everyone is allowed to do anything. The type of license that we normally advise is what is called a CC by attribution license. And that essentially means that anyone can do anything with the data, as long as they give the original creator credit, provide a link to the license, and indicate who originally made it. So this is essentially crediting you for creating the data, but then giving others the opportunity to do with it what they like to do. Last bit is actually on finding data. So Peter already presented this, but there are different scenarios that you would follow to look for data. You can Google it. You can go to specific repositories if you know that data sets are contained there. Sometimes you can search domain-specific repositories. As I already mentioned, there's not really one available for microscopy, but for other domains, for instance, geochemistry, there is a very good example available. Or it could be that you're just interested to browse data and to find data that you actually did not know existed. And then these European data catalogs, such as EPOS, are a very useful starting point to try and find your way through them. That was already actually the end of it. So with Excite, we've now created this publication process that you can follow. It's a stepwise process, and it's detailed in the documentation that's available on the website. And that should hopefully help you in going from doing the research in Excite to actually publishing the data in a way that is quite fair. That's it from my side. I'll be happy to take any questions, and already also wish everyone here a great summer break. Thanks.
Thank you, Richard, for this very interesting and stepwise. I feel that I feel equipped to now publish a lot of data.
Right. That's good to hear.
Thank you. So please, if you have any questions, you can put them in the Q&A or the chat, and I would be happy to pose a question for you, or just raise your hands and I can give you the floor. So in the meantime, so my burning question is actually, so why are there not Earth and Environmental Sciences disciplinary repositories yet?
Yeah, that's a very good question. Usually the problem is that someone has to host them. So there has to be an organization that at some point steps up and says, okay, this is important enough. We want to do that. And there has to be a community behind it to sort of enforce that. So with the chemistry, they are fairly well organized internationally. So for them, at some point they came together and they decided on a number of specific repositories for specific data sets belonging to geochemistry, and to just organize that themselves. They have the advantage that the data sets are not super large in terms of volume. So those committing to hosting this, they're not committing to a very large data storage need. So yeah, it was just for them perhaps easier to do it yet than it's in our domain. Yeah. We are always looking with one eye at should we do this as Excite, but
Yes.
It's also quite a commitment, because you are committing to storing the data and keeping it there for the next few decades. So you need to make sure that you create a structure that is future-proof as well.
Yeah, no, definitely. But we will keep our eye out to any opportunities, I think. So I don't see any questions from the audience, but with the licensing, I was wondering, so what would be the rationale to go for one or the other? So we have kind of like from the Excite side, we have a kind of like that we give an advice, and we advise a certain license form. So what would be the rationale to go for, I don't know, a more closed one or a more open one?
Yeah, it's a partly a preference thing actually, and that's why there's such a range. Some people do not like their work to be used commercially, either from a personal perspective, or it can be that the funder, so those that actually paid for the acquisition of the data, don't allow you to make it available in a commercial manner. Share alike is often used when you actually don't want someone to alter your data set. So say you spend a lot of time structuring something, and that in itself is a very nice coherent data package. Then sometimes people just don't want others messing with that, which could potentially like break some aspects in the way the data is set up, or there could be various reasons why people don't want that. Yeah.
Okay. So there are some things to consider there.
Yeah.
So I have a question here from Thomas Griffith. I hope I pronounce your name correctly. I think you can.
Yes.
What's your
You
question?
can you hear me?
Yes. Yeah.
So I have a question. So I don't know about you, but when I measure, I often generate data which I already know is not useful or even wrong.
Yeah.
Like because I have to do a test map because I have to check the settings, right?
Yeah.
Or I did a map and I pressed something wrong and the whole thing is useless. Or I forgot to change the name of the phase in the microprobe, and then these 17 points are called olivine when they should be clinopyroxene.
Yes.
So I mean, I guess the obvious answer is yes, we should just every time we do that, we should go through our data and check and delete all of this stuff. But like, I want to hear a bit more of your kind of practical, how do you really approach it in a real life? Like, do you leave those test data sets in there? Do you delete them? When do you delete them? How do you deal with errors, that sort of thing?
Right. Okay, so there's my personal opinion, and there's sort of what the European Commission wants. So what the European Union wants is they think that there is value in all data, so they essentially want you to publish all your raw data and put it out there. My personal opinion is that there's no point in doing that. I would rather have one good data set than 10 that contain data that is convoluted or just wrong, right? So I would always go for only publishing data that is correct as far as you can assess that, and that you actually think is useful for others. So I would not put in all your test data sets and stuff that you think that you know is wrong, because that will only sort of dilute and obscure the good data. So that's my personal opinion. I don't know. Yeah, I don't know, Thomas, if you have experience with publishing the data, but if you've made certain choices already in the past.
I mean, I would always fully curate my data set, right? But
Exactly. Yeah.
It's all about the amount of time, and the more automated the process becomes, the more the problems come. Because if you're using a system which automatically, at the time of recording, feeds all your data into an electronic lab notebook, then it becomes a problem, because then what do I do with these test data sets? Can I send them to like a different part of the notebook? Like.
Yeah.
It's a good question.
Yeah. In the end, you as a human have to decide on what data you want to put out there, and it's more like the flows from a lab notebook. Like if it stores already like the acquisition parameters, then that helps you that you don't have to write them down yourself and then have to copy that and then digitize that and whatever. But it doesn't
The
help
other problem I have
selecting
is
the data. Yeah.
like when you have a machine, it's not always possible to connect it to the internet anymore, because it runs on Windows 7.
Yeah.
And then I can't use an electronic lab notebook, which is also an issue.
Yeah, we have that as well, a lot actually, especially with the Windows 10 stuff. That even getting data out of there is difficult nowadays.
Yeah.
So 2 steps forward, 1 step back.
Yeah, but you seem to be making lots of progress, so thank you very much.
Thanks.
Great, thank you for your questions, Thomas. Very insightful. So I think, we went a bit over time already, so I hope you enjoyed this webinar, and thank you all for being here and following this webinar, and also for the other 10 that we did last year, as I gave you a little bit of an overview of. So in that sense, have a great summer. We will happily invite you back to very nice webinars we have lined up for you from September onwards. Enjoy the summer and have a great day. Thank you.
Right. Thank you. See you later.